This diagram tracks the life cycle of enterprise AI models. On the left, a massive volume are successfully developed in the lab, but on the right, 87% of models fail during deployment. Only a quarter successfully push pilots to production. Standard postmortems for these failed projects usually look for mathematical errors, model hallucinations, or vendor limitations. These failures generally trace back to a specific engineering choice: pipeline thinking. Organizations build bespoke, fragmented data paths for every project, connecting isolated data silos directly to a single model. This works initially, but breaks at scale. Connections cross, technical debt compounds, and the infrastructure collapses under its own complexity. Pilot purgatory is a structural data engineering failure. If the data delivery system relies on these brittle connections, the model will never reach production, regardless of how accurate its algorithm is. Most legacy pipelines were built for overnight batch processing, moving tabular data for static morning reports. Today's modern autonomous AI agents operate on unstructured data and require it in milliseconds to make real-time decisions. The flat baseline represents the data the model was trained on, but real-world production data constantly evolves. This is data drift. When production diverges from training assumptions, the model's accuracy drops without any code breaking. To manage this, many organizations rely on manual governance. Compliance teams must review and approve every pipeline update. In high-stakes industries, this manual review creates a deployment bottleneck that can stall a project for months. Maintaining these brittle point-to-point connections also creates a hiring trap. Engineering headcount has to scale exponentially just to put out fires and prevent the existing infrastructure from collapsing. In this environment, the legacy architecture built to support AI becomes the primary operational and regulatory risk to the entire project. Escaping the pilot trap requires moving toward a different architectural logic: platform thinking. Instead of rebuilding infrastructure for every use case, a platform defines common, reusable patterns. As this layered architecture shows, multiple disparate AI models can all draw from a single, unified foundational data layer. This shift moves a team from reactive firefighting to proactive maintenance. Automated quality checks are built directly into the platform infrastructure, catching data errors at the source rather than downstream in the model's predictions. It also replaces engineering tickets with self-service access. Data scientists can find and use trusted data through governed contracts without waiting for a manual pipeline to be built for them. Moving to a platform model changes the economics of the department. It allows an organization to scale its AI output without increasing its engineering headcount in lockstep. Escaping the pipeline trap requires a sequenced execution strategy. The first step is mapping the architectural gap. You have to understand the distance between your current data estate and what your future AI needs will require before you commit to new vendor technologies. Step 2 is embedding governance into the ingestion phase. This means building automated data contracts and bias testing into the infrastructure itself, so quality is inherited by every model that uses the platform. Step 3 is the implementation of MLOps to automate the data loop. This circular workflow shows how continuous integration and delivery handle model training, deployment, and drift monitoring in a closed loop, triggering automatic retraining when the environment changes. Organizations that treat this architecture as an afterthought find that their AI initiatives eventually revert to the same failures that plague the pilot stage. Today, frontier algorithms and large language models are accessible commodities. Any organization can license the same intelligence. The true differentiator is now the speed and reliability of the data engineering loop. The organizations that can move from raw data to a governed decision the fastest own the market. This creates a compounding advantage. When a company can respond to market movements or fraud in real time, while its competitors are stuck in manual reviews, the gap between them becomes impossible to close. AI supremacy no longer rests on the intelligence of a model. It rests on the structural integrity of the data architecture that powers it.